Hello and welcome. This recording will be a bit different because I'll record my computer screen. Now, I have already uploaded because, of university and I had to study and I didn't really have the time to post anything on my YouTube channel. But I thought maybe I'll do a little bit of that and just do some sort of new mini series, we can call it, which is basically studying together. And what I choose to do is to do actually MapLab because to be honest, I don't really know it either, and on YouTube there's very little about it, you know. And yeah, I just thought about doing it, and so we learned together the basics of it. Now, what's different between MapLab and Arduino is that Arduino is more surface level, while MapLab it's more about more deeper than that. You need to be more precise with your orders, so it's not going to anything like that. And you'll see in a second what I mean when we start doing it. And we're going to do a simple exercise actually. We'll choose a small microcontroller, and not only that, but we will also connect it to an LED. I mean, pretend that we connect it to an LED, and our purpose will be to just make it turn on and off, and that's it. And you'll see it's a bit more work than Arduino again, because on Arduino basically you only need to say value or port equal high, port equal low, put a delay in there, and that's it. But in MATLAB it's a bit more different and you need a little bit more setup. So I'll pause it a second and then I'll be back. Now this will be the circuit that we'll use, or microchip, let's say. It will be the PIC16F84a. If you wonder from where I took the picture, where I got the diagram and why does it have like 17, 18, 1, 2, 3, 4, 16 and stuff like that, it's a simplified diagram from Multisim. I tried to build a circuit in Multisim, it didn't work. I didn't know how to move the hex file inside of it, but I'll do some Multisim videos too as well. And because I feel that that's important and we can do some fun stuff with it, especially since most people I think they work with simulations now instead. So this will be the diagram, and let me go a little bit over through it. VDD pin number 14, there's the voltage input, basically your flat 5 volt. VSS, now that one is the ground, you just plug in the ground here. Oscilloscope 2 clock out, you don't really care about that one much. Basically, you can input a sequence frequency in it. You care more about the oscillation clock 1, which you put the frequency that used in the simulation. For example, if in the simulation with MATLAB, I use a frequency of 1000 Hz, then I'll connect 1000 Hz through this clock here. Master clear, basically when zero input is put through it, then it just sets everything to zero. It just makes everything blank and starts all over again. Your default master is set, and we have the ports. Now what you'll notice is that RA, this port A, got only 5 value, got 1, 2, 3, 4, 5, while port B got 8 value, got 1, 2, 3, 4, 5, 6, 7. Again, they start from 0 because that's how with electronics it starts. It doesn't start from number 1, it starts from number 0 and count down. Now, it's very important when you work with MATLAB because MATLAB does not give you diagrams and does not explain to you how many ports are in there. So when working with MATLAB, then you need to have a second diagram or the original diagram of the microcontroller. Look through it carefully because as you'll see soon, you need to know the number of ports to do a proper input, output, and so on. And now that we see the diagram, and I'll pop it up when we need it, for now I'll just put it down here. Let's create our own project now. So in MATLAB you'll have this one here. Ignore these two, they are like other projects that I was working on. So let's do create new. You go to microcontroller, you do the standard project, press next. Now devices, we can either like scroll down, but I don't really recommend it, or you can just type it in. So we use the PIC16, F stands for family, 64A. There you go. In case you're wondering about the F. And the tools, remember to take the simulator because you basically are creating a simulation, so you can like debug it and also see the outputs through MATLAB. Our families, so we press next. You will usually code in XC8, which is a little bit similar with C program. And again, the MATLAB has similarities with C program, but it also uses its own language too. So it's a combination between its own language and C language. And you'll see what I mean in a second. Project name, let's put video 1, like that. This is the location where it saves anything like that. It's kind of useful so you know from where to get the hex file in case you want to try to put it inside the, how do you call it, multisim. And there's our video 1 project, which is here. I don't know how to make, I don't think I can make these ones invisible, so I'll just leave them like this. Now the next thing you want to do, because you might be confused, like, well, basically nothing happened. Well, ignore most of them and go straight to source file. You'll notice it's empty, but if you right click, go to new, and you create a new main C. I'll just call it new main because we don't really care that much about the name of it since we'll have only one file. I mean, if you have multiple zip files, then yes, you'll put more attention to the, and details to the titles and things like that, so it doesn't get confused or mixed up. But because we'll have only one file, and again, very importantly, MATLAB can read only one file at a time. It can read two of them at the same time. It can read only one at a time. It can do one process at a time. I think that's a way to redirect it at the end of the process of the new main C to redirect it to a new one, and that way you separate them and make them more compact. But again, it can read only one at a time. Now, what you'll notice here is this stuff here. Basically, the file name, the author that you put your name in there, and then when it was made. Also see that includes the XC language, which is xc.h, that's the library, like in C language, and you'll notice that it's a void main void and a return. Now, I don't really use this one, and they didn't really bother to put the hello world thing, but it's fine because you can't really print in this. Now, what the university provided me, which was very nice, provided everybody, not only me, it's this here. It's a template, and that's you made one with a while inside of it, like an infinite loop inside of it, because you also need to manually put an infinite loop too, and it really adds all the information. It's like the proper way to do it, and it helps you keep everything organized. So I'll just copy that and I'll paste it right here. There we go. Just a second. I also need to open something else. All right. Now, the university, basically, when you do a file, you also need to put the name of the file, your name, your date, revision number. I think this is more of a university thing, so I'll just delete that one. There you go. Target device, compiler, what compiler used, and summary, basically what the program did. And you put it at the top. The person that opens it, reads it, looks at the summary. It's like, oh, okay, this program was made to turn on and off an LED on a certain period of time. Now, configuration statements include files, connection information, stuff like that. For now, we will do it step by step. You can have a look through this if you wish, and I'll also probably leave in the description the formats. You can just like select it, copy and paste it the same as I did. We still have the void main void because you always need to have this one. However, we also have a while one loop, which is basically an infinite loop, and you usually put your code that you want to do it forever in this one here. Because again, I don't know if you did the like in Arduino, because in Arduino you also have an infinite while. If you put a command in this one, it will execute it once and then it will reach the end of the program and stop. But if you have a while one in here, and it executes the program, then it turns back in, it executes it again and again and again, so it keeps on forever, meaning that the program doesn't just suddenly stop. Alright, now the next thing that we need to do is if we go to configuration bits, which is down here, or another way to do it, I think it's, let me see if I can find it. It should be somewhere around here. There you go. In production, you also have set configuration bits if you wish to do it this way. And let's do that actually. And here we'll have a few strange things. You may wonder, well, why do we need this? And this is one of the things that I told you about. It's important to know about the microchip, and it's also important to understand that MPLAB and the PIC family and stuff like that are a lot deeper than Arduino. Here you do the settings. You basically telling the program what you want the microcontroller to set up to do and what are the conditions of it. For example, this one here is the oscillation selected bits. I'm not sure what XTRC means, but usually you put it on high S, which basically will be high oscillation, high frequencies. Okay, and then at least this is what we are told to use, and that makes sense because we have set it to 1000 megahertz. This one is the watchdog timer. We will not use something like that, so we'll turn it off. And most of these options will be basically on and off options. Now, I watched a few videos about the subject, like about MPLAB, because even though they are very old, there are still a few of them in there, and they are a bit updated because MPLAB went through a update and become MPLAB X with version 5 and stuff like that. But basically, the way they said is that when the list pop up, because some of them will have, lots of them have like 20 options or stuff like that, usually what you do is you look to them and you turn off everything that you don't need and you leave on only the stuff that you need, or change the stuff that you need. Okay, so after doing so, because we won't need this tree and we are using the HS, we will generate the source code output, and this gives us the source code. And there you go. Yeah, it does. These ones are off and these ones are high. The only thing we need to do now is to simply take this and copy it. Oh, sorry. There you go. And we'll have configuration statements here, so we can just nicely put it under here. When somebody reads configuration statements and they see this this part here, they understand, oh, okay, these are the configuration statements. Alright. Now, next one will be the included files, which basically are the libraries. From a second ago, before I deleted what it was, there was a include xc.h, which is the compile specific library. So let's try this that one down. Let's see, where's the hashtag? There it is. Include space there you go, xc.h, and this one will be the xc8 compiler specifics. Of course, if you can already imagine, because we selected that we are coding in xc8, we will obviously need to always put this library in. If you don't put this library in, then of course the code will never work. Now the next one, library that we need to include will be include space stdlib.h, okay, space 2 lines here, and then this one will be the standard c i/o library. There you go. You may wonder what this i.o is, and I'll show it to you in a second. Because if you go to, let me see if I can find it. View, maybe? No? Where did it go? I guess I need to build it first and then we can see it. Basically, this IO's library allows you to do the IO view, which is down here, but It should be around here as well. I should see it. I'll notice it eventually. If I think I'm just overlooking it. But the idea of this one is, and let me make it a bit bigger, is that if you select to work with port A, you can simply click it here. It will show you the available pins. Again, as we saw from the drawing, there are only 5 of them available, so there are only 5 of them in here as well. Or port B. And basically what it does, it lets you see the changes through here, basically activating the simulation. So I'll put this one quickly back down. And it's a third and last one that will include. So include std lib. Oh no, I did a mistake here actually. .h. This one it's actually the standard C library. Basically, you can use C language codes. So standard C. Yeah, it pops up the error as a because we use it. Okay, that is seems there's an error popped in. Or not, or maybe because of the space here. No, what I meant to put here is stdio. There you go. And this will create the IO library. Alright, so now we also have the libraries, meaning that, and I always suggest that you include all 3 of them. You may not need this one, but you'll definitely need the C language library because it makes calculations and everything like that a lot easier. And you always need the xc.h library. Now let's go under and we'll have functions. No, we'll have definitions right here. Now, when you define something, it's basically like saying I want to use that thing or I want to use it that way. And here's what I mean. If I put hashtag define and then let's call it output, let's go to this output. Okay. Okay, I'll put lowercase bin as well. I'm afraid maybe it will like mistake the actual output to something else, but that's fine. Alright. And then we put trace A. Now you may wonder, what does this even mean? Well, what this means is basically, let me go back to the drawing, and if I'll quickly bring the marker up and I'll do color red. What they are basically saying is, we'll define this value here, this name here, which you named it output pin, and we'll define it as a trace A. What a trace A is, it's basically this whole thing. So all of RA, R1, R2, R3, and RA4, these ones now are following, I have the same name, have this name in here. So they are not really individual. When you call this name, you are calling all of these pins all together. You may wonder, well then, what if you want this one to be a 1 and this one to be a 0? Again, I will explain how that works and how we're going to do that. But just remember this. When you say trace A, you select all of them and you give all of them this name. You can do it with the other ports as well. You can say trace B because maybe you want to use more of them. And when you say trace B, instead of using trace A, and let me just delete this one, then I'm going to use trace B. So I'm going to use all 8 values from here then instead. But we are going to work with A because it doesn't really make a difference. We really need only one port. It's not like we need 8 of them to make an 8-bit converter or anything like that. So we can just work with RA. So let's put trace R8. Another cool thing that you can do, and let me pause the video to make sure about it. Okay, there you go, I'm back. Just want to make sure that I wrote it properly. Another thing you can do is you leave the name, but instead of saying trace A, you write port A, calling the port bits, and then you put dot R, oh, and there you go, it auto fills RO, no, RAO. And you may wonder, well, what does this one do? Well, basically, it's telling the program, okay, from port A, I want the specific RAO value. So basically, instead of saying, oh, we'll use all of these values, we tell it and give all of them the name output pin. We'll just say, oh, I only want this value, this pin here, and I'll give it this name here. So this pin will be no, pin RA0 will be the pin with this specific name. However, this will make things a bit more too complicated, so we are just going to settle for the other one, which was the trace A. Yeah, there you go, trace A. And some I don't know. Sometimes I feel when I'm coding in C or in any language program, I rely a little bit too much on the color change, because if I see the color staying black, then I'm sometimes afraid that, oh well, maybe I just put the wrong value or something like that. Anyway, so yeah, this is our definition. We call the entire port A, all 5 pins, and all 5 pins have this name here. Alright, now the next step will be to scroll down to functions and put 2 new functions. The first function will be void set up void. Now you may recognize this one from C language, basically making functions and calling them. You do a void setup void. We don't really need it because we won't do a lot of setup, but it's important to do a function with all the setup lined up nicely, because when somebody will be like, I wonder what values they use for the setup, maybe the problem is there. You just double click setup, you'll go at the bottom, you'll see like, oh okay, in the setup function there are this and this value. Alright, so it's better. If you don't want to use the setup and you don't want to bother with this function here, then you can just simply write it crudely underneath the main or in the while if you want to do delays and stuff like that. But again, I don't know, if you did C language, and I'm very certain, like 100% that you did C language before you do MPLAB, then you know that is very poor practice to not write functions and just write the raw code in it. If you are doing MPLAB before doing C language, then I don't know, you'll have a very difficult time, and you are very brave for doing so. Anyway, and another void that we'll need for this case, for this example, because we want the LED to also turn off and on and basically blink, to also show you other functions that MPLAB can do. So we'll call also a delay function. We put void because what void it does is basically any type of value can be inside of it. If you put integer or character inside, it will be like, okay, in this function there are only integer values, or in this function there are only character values and stuff like that. So I should just put void. It makes it easier, it's faster, and the level of coding is not so high that I'm required to specify if it's integers or floats or characters. Alright, now beneath the void function, the void main void, what we'll do, we'll go to call installation function if used. So we'll just say set up, and then you do the 2 brackets, the important they will be empty inside because it's a void, and then semicolon to close it, and that's it to go the setup when we actually build the setup. Now if you go beneath the while, no, actually let's build the functions first, because it doesn't really make sense to use the shortcut before building them. So the setup function, okay, let's build it here. the way we do it is we say void setup. Important to use the same name, and then bracket void again. Now we put a squiggly line in here, press enter. Okay, I didn't know what the problem with that one was. Alright, press enter, and then we will say that the, what was the name of it? Output pin. Okay, we'll say that output pin, that's the function that we used, basically will be equal to 0. Now you may wonder, what does this mean? Does this mean that all of them are low, that all of them will send 0 volt? No, it does not mean that. That's what I thought at the beginning. Basically, what we are telling the program now, and again, it's kind of what makes it annoying, is that, okay, let's go step by step again. We defined all the ports in A, all of this, as the output pin. So basically what we did, we click on it and selected it. Now, what we did here with that value, it's now after we selected it, we told all of them will be outputs. So they will not take inputs inside, all of them will be outputs. And that's why you sometimes use the port A bits RA0 or RA1. So you can set each one individually if you wish, as a 0 or 1 as the output or input. And as you inspect it, if 0 is the output function, then 1 is the input function. And if you put here a 1, then all of these port A pins will become input ports. And that's why you have RA and RB. You can set RA as all input, and you can set RB as all output if you wish to do so. And basically the information comes in through RA, gets processed, and then it comes out through RB and stuff like that. But because we use with an output, because we want the LED to lead on and off and on and off, we're just putting a 0 because output is everything we need to do. And we also put a nice comment in here. So now the microcontroller will set port A to output. There you go. I'll just write output normally. Alright, so that's the setup, and basically what it does, when it reaches this point, which is the very first command, it will go down here, pick this up, it will tell the program, okay, all the A ports, they are outputs. So what you need to do is to give a value out, not to take one in. Now let's go to this one, which are the other functions, and we want to use the delay function too. So void delay, void squiggly line, enter. Alright, now we don't simply do integer I, because that's not a good one, because then it will get stuck to that value to remember it and save it. We use unsigned integer I. That's how we are supposed to do it. And we also use unsigned integer L. Now, why do I have two of them, and how do you create a delay in this program? Well, basically, you can't. The microcontroller runs at the speed based on the frequency that we have set. And I think we have set, let me show you how to set the frequency actually. So if you go to, okay, let me explain it. If you go here to video 1, right click it, you go properties, then you go to there you go, no wait, libraries maybe, loading, simulation, there you go, simulator. If you go to simulator, you have the instruction frequency, and it's set to 1 megahertz, which is basically high, now very high. So what you do, you use that 1 megahertz of frequency, and manipulate it in such a way that it takes time to do all the calculations, and that way you create delay, because microcontrollers can seriously be slowed down if you do a calculation, a loop inside the loop. What I mean by that is, I'll show you it for now. You do the for in C language, which is for, you select L equal to 0, semicolon, L less than 50, semicolon, L plus plus, and basically add it by 1. And then you do this quickly bracket, press enter, and now inside this quickly bracket, so inside the same loop, sorry, I put capital N instead of little n. Here you go. Inside that one, you do for bracket. Now we use the other value, integer I, and we'll set that one to 0, then semicolon, I less than 20, semicolon, I plus plus. Okay, and this one is closed. Let's see, so this side is opened, this side here. Okay, we need to open it and close it, so there you go. It's opened and closed at the same time. Let's put it here so it's actually nicer. There you go. So yep, all of them are opened and closed. Okay, now what the program will do when we call this function delay, it'll look at it and be like, okay, I need to count 20 times, and then after I counted 20 times, I increase L by 1, and then I count 20 times again and increase it again by 1, and so on until it's fulfilled. And this one will seriously slow it down. Now the problem with this is it's not very precise. There's no formula to be like, okay, if I put this value of 50 here and if I put this value of 20 here, then that's precise 10 milliseconds. It is not a formula you can really calculate. You will have to do guesswork, and I'll show you how to do guesswork on it, but it shouldn't take so much time and you shouldn't be like dead precise with it either. Now we go back to the while. So let me just delete some of this. There you go. So now what we do, which is basically be the last step, is we are going to give the commands, basically to actually turn the LED on and off. All we did by so far was the setup, was the preparation to do this. Now we call the function, which will be output pin. There you go, and that one will be equal to, it turns to the happy blue color, meaning that it recognizes it. And this is how you write it. You don't write hi, you don't write 1, you write it as, and be careful of this, 0, B, meaning that output binary, and again, look at port A, because this is port that we use, either in here or the diagram, and you'll see there are 5 of them, it will be 0, which is the highest value, which is this port 4, which starts from this one, from RA4. Then RA3 will be a 0, will be nothing out of it. Then RA2 will be a 0. Then RA1 will be a 0. And then RA0 that we'll use will be a 0. So we used 5 values, the 5 values that the ports have, the 5 ones that are here. Okay, so then close the semicolon, switch on, and no, switch off the LED. Now what we do here is we'll call the delay command, so we'll have a little break so we can actually see that it turned off. And then again we do the same thing, output lower pin equal with, again, output binary 0 0 0 0, the first 4 ones from the highest towards the lowest, and then at the lowest 1, close it with a semicolon, and then this one will be switch on the LED. Alright, enter, and then again we call the delay function, delay like a bracket. There you go. So how do we know if it works? Well, it will show it to you here. It will tell you the bits that are active and also the decimal value. Now, how do we test it? Well, we have this here called the debug main menu project. Now, if you press it, it will basically tell you if everything is. Oh, there's an error actually. Warning error. Is there a problem with the delay? Delay. Oh, I misspelled it, sorry. Delay. There you go. I also don't like the errors in here because sometimes they are very confusing. This is library error, which is basically outside of the code. So if I click it, it's around here. Sometimes what you want to look at, it's actually inside the library error. And also, remember that, okay, delay, that's correctly spelled. Okay. And sometimes it wouldn't even show it to you here. It would just tell you it's a library error. It wouldn't really specify which one is the problem. And now if we like reclick again, it should be fine now. So let's see, yeah, there you go. That was successful. Took 3 seconds. It does the saves. It's launching the stuff, and that's it. Now the app is running. And now if we go here, you'll think like, well, why don't I see anything changing? Well, MATLAB doesn't automatically update. It doesn't update with every change because that will slow the program down by a lot. So what you do is you pause. Okay, it happened that we pause when it does 0. So if I pause again, there you go. You'll see that in 3A, because you selected this option, it's a 1. So the output of RA0, it's 1. Okay. But a better and more actually working way to do it will be if you click these numbers here, you can add a breakpoint here and here. And basically what it does is next time we do the debug, and it also helps the timer too, it will stop the program at this point. It will let us observe it, and then we need to press this button to go to the next breakpoint, but on the next one it will stop. So if I press continue, it did a delay, then it stopped again. So when I press continue, then this value will change to a 1. It will do the delay and it will stop at this point. So I press continue, and there you go. The value is 1. It's at this point. It stopped right before doing this part of the program. And if I press it again, it will become from a 0 to a 1. Yep. No, from a 1 to a 0. Because you also can see from the decimals and from the activation here. There you go. Now it's 0, 1, 0, 1, basically going on and off. But again, you don't really know how fast it goes because it's a simulation. So what you do is on the tab here, it's another useful thing, which is the stopwatch. When you press the stopwatch and you have breaking points, it will basically tell you the time between them. So we are here at the moment. If I press continue, then it gives me this time here, 16.86 milliseconds. So from this point till all the way back to this point, it took only 16.86 milliseconds. If I press continue again, then from this point to this point, it took only 16.858 milliseconds. Now, if you want the timer to be longer or lower, and remember to actually finish your debugger so you can do the changes, you can change the values here. So let's say I put a 2 in here, I'll make it 250, and now it should take a lot longer to actually process. So I'll do the debugger because milliseconds maybe is too low, and I think this one will be about a second. There you go, it's built. We go to the stopwatch. This one I took the time to actually reach this breaking point from the setup, so ignore this one here. We press continue, the delay went through, and now it significantly increased to 84 milliseconds. Let's see if we can actually do it better. Let's see if I can. Let's change this out to 2250. Let's see if we can actually make 1 second go by, or 2 seconds, or something similar to that. So stopwatch, continue. Now it's telling milliseconds. Now it's about 758 milliseconds. Let's increase this one as well by making 220. There you go. Let's see on the stopwatch. Oh god, now it says it took a lot longer. This one was a bit too much. Now it's 7 seconds instead of 700 milliseconds. Okay, let's stop it. I don't know, I'm having a bit of a fun with this. Let's change it to about 70. Should be fine, I guess. Yeah, this one is the last time, because I think you got the idea. You wait, the program builds. It will move you to this page here. You got the stopwatch, and then you press from the breaking point. You press continue. You can see the delay going through, and then it stops right before 2 seconds and 55 seconds. No, 2.55 seconds. That's fine. It's close to seconds, and there you go. And again, you can see the outputs in here. See, now it's a 1, now it's a 0. And the advantage of Trist is that you can basically manually just do it yourself, just add the values yourself. So if I just quickly lazy copy paste this one, I'll paste it here, I'll paste this one here as well, we can easily do the following. Let me put some breaking points in there as well, here and here. I can just be like, okay, so this one will be a 1, 1, this one will be a 0, 1, 1, 1. There you go. So basically you can just set it a lot faster than Arduino, to be fair, to set up the high and low values, but it takes a lot more time to like set up to do so. So basically, by using the trace value instead of the unique separate pins, because the entire port section, this entire section has the same name, we can easily control them. So if I forgot to pause it, there you go. I need to like stop the simulation, then build it again to actually make the changes. There you go. Let me go to the iOS view. Let's make this one bigger so you can actually see better. There you go. So it's here. Now press continue. As expected, this one will become 1 when I'll continue. And now this one will have these values here. So highest will be 1, 0, 1, 0, 1. And you'll notice that on the value, this is the hex value, I think. And on the decimal, it will be a big difference, because the decimal is basically the binary calculation. So the highest one, I think, will be like 64. This one doesn't count. Then this one will be, wait, 1, 2, 4, 8, 64. Yeah. So 64, that will be that'll be 4. That'll be 68, and then plus 1 will be 69. So the decimal, when I press next, should be 69. Oh no, it's 21 actually. Never mind, I guess I did it wrong. I'm not 100% familiar with MATLAB. I was expecting to go that way. Yeah, did it wrong. 1, 2, 4. 4 times 2, that's 8. Oh no, 8 times 2, that's 16. So yeah, I did it wrong. So it's 16 plus 4. That will be 20, and then the plus 1, yeah, that's 21. Yeah, that's correct. So yeah, I don't know why I said 64 after 8. Alright, so that will be 21. And then when you do this program here, it will give us a different value. So now these pins will become the actual active ones, and so on. So you can easily make sequences with the port and everything like that. Okay, this will be the first look at it for now. I will do some multi-sim too, and I hope this helps you. To be honest, like the biggest problem that I had when I started with MATLAB, it's I simply did not understand how to actually do this. How do I simply set a port to an output or input? Because that's the very first thing that I should have learned, but they didn't really went in great detail about it, and I don't really see videos went in detail about it to like explain that specific thing. But don't worry, together we'll like find out how to do various stuff. Alright, so this is the video, and I'll see you guys next time then. Bye.